Really excited to be here and really pleased to be here to talk about our work on Flowkit. I'll share my screen and hopefully everyone can see that, and I'll get started. So yes, as I said, thank you so much for the invitation to speak today. I'll start with just a quick bit of background about FlowMinder as an organization. So we're a non-profit organization with around 30 multidisciplinary staff. We work closely with mobile network operators, governments and intergovernmental agencies. And our journey really started with the 2010 Haiti earthquake and the subsequent cholera outbreak. And since then, we've been pioneering the use of mobile operator data for the humanitarian and development sector. The main type of data that we work with are called call detail records. And these are generated when a subscriber makes or receives a call, sends or receives a text message, or uses mobile data, which we collectively refer to as network events. And this data is usually used by mobile network operators for billing purposes. But from the perspective of studying mobility, there are three key features that we're interested in. There's a subscriber identifier, there's the time of the network event, and there's the cell tower that the event was routed through. And from these, we can construct individual trajectories, which when grouped or aggregated in a sufficiently large number of these trajectories, we can study the mobility patterns of the population as a whole while protecting the individual privacy of each subscriber. Using CGR data has a broad range of benefits. This data is automatically generated by mobile network operators in near real time, meaning we can quickly produce up-to-date insights into population distributions and movements. They also cover broad geographic and time scales, geographically up to the national scale. What's especially relevant to the humanitarian development sector is the large population coverage, particularly in low and middle income countries where GPS-enabled smart devices are less widespread. So Flowkit itself is a piece of open source software that we've developed for the secure processing, analysis, and granular access control of CGR data. And we've designed this so that it can be installed on a single server within an MNO's firewall. What Flowkit does is it processes pseudonymized CGR data into anonymized aggregates, which can then be analyzed using standard tools on a personal machine. So it takes lots of the big data work out of analyzing this form of data, which can be up to billions of data points. What this does mean, though, is that the outputs from Flowkit do need further analysis and interpretation to provide useful insights for decision makers. Flowkit itself has three main components. There's an ingestion and quality assurance component, a processing component, and an authentication and controlled access component. Firstly, the data ingestion component reduces the effort to get the CGR data analysis ready. This is done by automatically ingesting new data and automatically running quality assurance checks. But it also includes storing the data in a data model that is optimized for the queries that we use to generate the anonymized aggregates that are used for further analysis. The processing component provides a suite of methods that's been developed and tested by FlowMinder. And these methods have also been developed to be efficient on a single server. As I said, Flowkit is designed to function in resource-limited situations. Flowkit also integrates GIS to facilitate geospatial analysis and has a modular design to allow for growth and extension, the addition of new methods as we develop these over time. And then finally, but perhaps most importantly, there's the authentication and access control component, which ensures that the outputs are anonymized, protect individual privacy, provides an interface which can be integrated into other tools, and permits granular control over the outputs that a user can retrieve. Obviously, mobile phone data and CGR data is very sensitive personal data. So the privacy of mobile phone subscribers is core to the design of Flowkit. This is why individual level data and its processing always remains within the MNO's premises and behind their firewall, and hence the reason why it's been developed to sit on a single server in the MNO's firewall rather than extracting the data to anywhere else. Flowkit also only allows anonymized outputs to be retrieved, and this includes redacting outputs to enforce k-anonymity. It also includes granular access control, as I've mentioned, which facilitates data minimization by restricting what each user can retrieve, and all queries are logged so that any activity can be audited later. And finally, the CGR data accessed by Flowkit is first pseudonymized to further reduce any risk of re-identification. So this means, for example, replacing the true identifiers for the individual subscribers with randomly generated new identifiers to prevent direct re-identification if there was a data breach. But as you can see, there's multiple layers of protection here. So moving on to an actual demo of what Flowkit looks like to work with. First, I'll just talk through a few of the prerequisites for using Flowkit. So as I mentioned, Flowkit first needs to be installed on a server within the MNO's premises and linked up to a database containing their pseudonymized CGR data. The CGR data itself, the locations of the cell towers that are routing the network events, and the geographic boundaries for the country also need to be ingested for the period of interest. The next step involves having permission to access the required aggregates by a system administrator. The Flowkit API needs to be exposed as an accessible URL to be able to interact with it. And lastly, the user also needs to be familiar with the Python data analysis ecosystem and needs to have installed the Flow client Python library, which I'll show you in a second. More information about this can be found at our website, but I'm also very happy to answer any questions about this afterwards. So when you actually open the software, what you'll see is a sign-in, and if you sign in, then you'll be able to see this second screen where you have your active tokens. And if you don't have any active tokens currently, then you'll click this plus sign here, which will take you to page 3, where you'll be able to create a new token. And this involves giving it a name, which is a shorthand for you to be able to recognize which token it is. And down here is where you'll select the types of queries that you want to be able to generate with this token. Often you'll see that some of these will be grayed out depending on the permissions that the system administrator has granted you. And that comes back to this idea of data minimization and ensuring that people only have access to the data that they require. Once that's all completed, then you should see a screen like this where you'll be able to see the active token with its name, and you'll be able to copy the token itself into your Python environment. So here you can see an example of what that token might look like. And then you can use that with our Flow client package to then connect to the API's URL. And provided that all goes smoothly, then the next step would be to just check that the connection is working, and you can use a function like the get available dates connection query just to get a list of the dates that are available to you for the analysis. Once you've got the connection up and running, the next step is to define the queries themselves. So here, the example I'm using shows 2 queries which estimate the resident counts per district for an area in Nepal before and after the onset of a crisis. What we can see here is the first query is before the crisis, and we've given it information which is the start date and the end date for the period that we're interested in, and we've defined the method that we want to use for counting the number of subscribers resident in the area during that period. This one involves looking at for each subscriber which districts they had the most mobile network events on a given day, and then for the period, what is the area in which they most often had the most number of network events per day. I can go into a bit more detail about these methods if there's interest, but the main the main part of it is that we've got sort of these two queries, before and then after, and each is aggregated to admin 3 level, which is the district level in the pool. Because each of these queries would give back individual level data, for Flowkit to give us anything, we need to then wrap them in a spatial aggregate command, which will then take this individual level data, which tells us where we estimate people's residents to be, and it aggregates them so that it gives us a total number of residents per area, protecting individual privacy. We can then use the parameters function here to check the parameters which are being used in these queries as well. And if we're happy with that, then we can then run these two queries using the getResult function, and just checking the results that come out. We can see here a series of P codes for different districts, and a count for each of them of the number of subscribers who we estimate to be resident there. We can then do some further processing in Python. Here we're simply merging the two query results for before and after into a single data frame, and we're calculating the percentage change. Once we've done this, then we can also look at how we would want to visualize this. And one of the features that is built into Flowkit is the ability to carry out geospatial analyses. So here we can see that there is a getGeography function built into FlowClient, which allows us to extract a GeoJSON for the admin 3 districts in Nepal. And once you've got this, then it's very straightforward in Python to then map the data that we've extracted from CGR data, the counts of the number of residents, or in fact here we're looking at the percentage change in the number of residents, comparing before and after a hypothetical crisis, and produce that and turn that into a map, which can then be used to conduct some further interpretation of the impact of the crisis or the disaster on the number of residents in each area, and draw some insights about, for example, the displacement of people from areas affected by an earthquake. This here is some demo data that we're working with. It's not real data from Nepal, but hopefully gives you an idea of what these maps could look like just using Flowkit and some simple Python packages. With that, I'm very interested in hearing some questions, and very excited to hear your thoughts on this. So yes, thank you very much.